In this section, we'll try to understand a route filtering in BGP concept. Now, the first thing what we'll learn in this video is we'll try to understand what is exactly route filtering. And if I talk about route filtering concept, it's more similar to IGP, what we have learned in the basic CCNP studies. So anyway, I'll quickly give an overview of what is route filtering and what exactly it is going to do, the overview of the route filtering, and then I'll explain you some couple of examples or scenarios when and where route filtering is more applicable in BGP. And then probably the third thing, I will explain you some of the methods, some of the different kinds of implementation of route filterings. So let's get started first with what is exactly route filtering. Now, route filtering concept, as I said, it's more similar to your IGP route filtering. Now, by default, if you configure a BGP on any couple of routers, I have some couple of routers here, and I want to ensure that I'm advertising 10 network here, and I want to make sure that this 10 network should get advertised to router B. Let's say this is router A, B, C, D, but it should not get advertised to router C and router D. So that's what we call as route filtering. So now either you can implement outgoing direction, or you can even define rules saying that any update, maybe 40 network, it should go to C router and B router, but it should not get into the BGP table of router A. This is what we call as inbound direction. Now you can apply, just like ACLs, we can apply either inbound or outbound. When you define outbound, which means the routes will not get advertised outside to this specific neighbor. And when I define inbound, it will be advertised by router B, but the router A is not going to install those routes into the BGP table. Now this is something more similar to what we have learned in the basic IGP route filtering concepts. Okay, so I'm not getting into much more detail, so I discussed the same thing in IGP as well here. Now the next thing, when and where this is applicable. The next thing, we'll see a couple of scenarios where BGP route filtering is more applicable. And the first scenario, if you remember, in the basic BGP studies, we have learned that whenever I'm connecting to my autonomous system number and I'm running BGP and this is my autonomous system number, either I can exchange the complete routes, or I can just specifically receive only specific routes, and for all the remaining routes to reach internet, I can have a default route configured. Because by default, whenever you configure eBGP between any of these two routers, whatever the routes, ISP is going to maintain. So ISP maintains all the routes on the internet, and I want to ensure that the ISP do not advertise each and every route to my specific autonomous system number. Now why I don't want? Because I don't want any overhead on my router, because if all my routers start installing the routes from on the internet or from the ISP, now my BGP table is going to be very big, and I really don't want. So in this kind of scenarios, what I can do is, the service provider, what you can do is, you can just filter the routing updates, all the routing updates except a few routing updates. Maybe you want to reach specific networks, you want to do some path manipulation. Maybe you want to reach 50 network, 60 maybe you have some servers on the internet, or you want to access some specific networks and you want to do some path manipulation for that. So now only specific routes will be advertised, and more specific routes. For all the remaining routes, or for all the remaining routes, we just configure filtering. Either you can apply outbound, or I can apply in of my autonomous system number. So generally the customer is not much experienced in using BGP, so probably we don't do much on the customer end. So the service provider will handle these things much better than a customer. Now this is one kind of scenario where we can apply some route filtering, which is more common here. And there's one more scenario where you can also use route filtering is, again I'm going to take the same scenario here. I got ISP 1 and ISP 2. Now this is my ISP 2, and in this scenario, now most of the service providers do not want to propagate the routes from the customer, from the one service provider to another service provider. So let's take an example. This ISP is advertising some routes to the customer, and in my autonomous system number, I'm connecting to two different ISPs, ISP 1 and ISP 2, and the service provider do not want them to advertise whatever the routes received from ISP 1. It should not get advertised to ISP 2. Now if that happens, anyway it doesn't make difference much, but if that happens, what happens is you are advertising the routes from this side, from ISP1, and it's going to my autonomous system number, and it goes to ISP2 again. So which means to reach some specific networks, maybe 50 dot network, now this ISP2 is receiving two routes. One route is this direct route, and there is one more route via like this. Now maybe it is going to see the autonomous system hops, maybe this is 8 hops, and maybe the route from the customer may be just 5 hops. Now based on this, ISP2 is going to use the shortest autonomous system path information, so maybe it is going through the customer to reach that specific networks, and my customer or my autonomous system number is going to become as a transit for all the traffic. Now which means, which I really don't want. Just to avoid this kind of scenarios, what we'll generally do is the service provider will ensure that any routes, whatever the routes coming from ISP1, it will be received by the customer, and those routes will not get advertised back to another service provider. If that happens, probably there is a possibility that my autonomous system number may act as a transit. And one more scenario where we can also apply some route filtering in BGP is like in your network you are using some private addresses, as well as you are also using some public addresses for some public servers on the internet. Now when you might be advertising both the networks in BGP, but when you are advertising these routes to ISP on both the sides, you want to ensure that when you're advertising, we advertise only the addresses which are allocated, sorry, not private, it has to be only public. And we want to ensure that we filter out all the private addresses when we are advertising to ISP, because internet do not recognize any of the private IP addresses. So there is also one more scenario where the BGP route filtering is more applicable. So in all these kinds of scenarios, we can use any of the BGP route filtering method. Now, there are a couple of ways in doing implementing these route filtering methods. So either you can use something called distribution list by using some ACL. Now what I can do is I can match all the networks, whatever I want to deny in I can write an ACL and I can match all the networks. I can simply say deny whatever the networks we have, and then finally I can say permit any inside the ACL statement. Or if you have more permit statement, you can simply say permit, and by default, and then you can say deny all, something like this. So when you apply filtering, it's going to only permit or deny the routes whatever is defined in the ACL. Now similar way, either you can use distribution list, or you can also use something called prefix list instead of ACLs. So prefix lists are more efficient way of filtering the routes, because prefix lists can match the networks based on the slash value. So that is one advantage we get when you compare with ACLs over prefix list. Prefix list over ACLs. So now in prefix list, individual entries can be easily edited or deleted. That is one advantage we get. Apart from that, prefix list is like a tree structure, and it is not scanned sequentially. So which means it is going to have some less overhead on the routers, because ACL works in a sequential order, but here it is not like that. And one more advantage we get is IP prefix list matches based on the slash value. Now either you can use any of these methods, or even you can use some route map statements. We can also use some route maps, and to match the networks, again I have to use either distribution list or prefix list. We can also use something called BGP communities. Now BGP communities, if you remember, we discussed I discussed much more in detail regarding this BGP communities in a separate section. You can use some well-known communities like no export. When you say no export, it will not advertise those routes to external autonomous system numbers. So no export, no advertise, some of the BGP community attributes you can use, or you can also use your own defined community attributes. It's more easy way of filtering the routes. And apart from that, you can also filter based on the autonomous system path information. Now by default, any BGP update, if it is advertised, it's going to advertise the network with AS path information like AS 100, 200, 300i. Now using this AS path filters, I can match the autonomous system path information in that BGP update by using something called regular expressions. So regarding this AS path filters using regular expressions I have discussed much more in detail in a separate section. So this is something much more discussed much in detail in a separate sections, and then BGP communities also I have discussed in a separate sections much more in detail. So now probably in our next sections, in our next videos, probably we'll try to get into some BGP route filtering methods by using distribution list or prefix list and route map statements.